Then God said, "Let there be light," and there was light.
That, ladies and gentlemen, was perhaps one of the most well-known verses from the King James Bible. And in a sense, it accurately describes what the James Webb Space Telescope discovered recently. And that discovery could possibly change everything we thought we knew about the early history and evolution of the universe. You see, astronomers have been trying to study the formation of galaxies in the early universe for decades, as understanding this problem can help reveal some of the biggest mysteries of the universe, such as the nature and role of entropy in galaxy clusters, where supermassive black holes come from, and the origins of life itself. Unfortunately, for most of the history of modern astronomy, we simply did not have the technology to peer that far back in time, making the process of studying such an ancient cosmic period quite challenging. That is, until James Webb's recent observations of infant galaxies in the early universe, around 2 billion years after the Big Bang, which revealed for the first time that these baby galaxies ignited massive clouds of gas to trigger explosions of intense star formation. What's most surprising about this discovery is not just the fact that the interaction of the abundant gas clouds with the radioactive stars in these ancient galaxies triggered reactions so immense that the gas glowed brighter than the stars themselves, but also the revelation of just how abundant these shimmering infant gassy galaxies were when the universe was a mere 2 billion years old. The team of astronomers behind this research stated that according to their observations, nearly 90% of these infant galaxies in the early universe had such extreme emission features, which may have been the result of interactions between neighboring infant galaxies in close proximity to one another, causing gas to cool and triggering the immensely energetic process of the formation of stars. And given the natural state of darkness of space, these shining cosmic jewels that James Webb observed were likely some of the first sources of light that brightened the early universe. Without their luminosity, the cosmos would likely feel cold, gloomy, and devoid of any spectacle of awe and magnificence. The research data collected alongside these new observations was part of the JWST Advanced Deep Extragalactic Survey, or JADES for short, a project whose goal is to explore the earliest galaxies and open the door to future insights about the universe. All this would not have been possible without the James Webb Space Telescope since before its creation and deployment. Astronomers simply didn't have a technologically advanced space telescope with enough depth and resolution to be able to get a clear picture of star-forming galaxies that existed around 12 billion years ago. Now, as amazing as this discovery is, it might be hard to believe that there's actually a lot more to it than just stunningly bright gaseous galaxies. You see, when James Webb detected these galaxies in the early universe, which appear as glowing little red specks surrounded by the darkness of space, it simultaneously spotted an unexpected abundance of those with cyclones churning in their centers. Astronomers believe that the most straightforward explanation of these tornadoes at the heart of these hidden little monsters is gigantic black holes weighing millions of suns, which are igniting the gas clouds into a frenzy, thus explaining their red color. But here's where things get interesting. According to our current theories about the history and evolution of the universe and the formation of galaxies, these monolithic black holes should appear much later in the cosmic record than this observation suggests. The fact that we found them this early in the universe's timeline means there is a significant gap in our understanding of the universe. As such, astronomers will have to wrestle with the question of whether such humongous black holes become that way because they grow extremely rapidly, or were they simply born this big? One thing is certain, however, very few astronomers expected to find so many young, hungry black holes during the early history of the universe, a fact that will undoubtedly force us to rethink well-established theories of stars, galaxies, black holes, and more. With this new discovery, astrophysicists like Marta Volonteri, a renowned expert in black holes at the Paris Institute of Astrophysics, and Xiaohui Fan, researcher and associate head of astronomy at the University of Arizona, now have to contend with the influx of giant black holes in the early cosmos, something that would be considered impossible under current established theoretical models. The story of this cosmic mystery actually begins 20 years ago, when Fan's research team at the time spotted a brilliant distant quasar with a redshift value of 5, corresponding to an age of just 1.1 billion years after the Big Bang. For those who don't know, a quasar is a galaxy that is anchored to an active supermassive black hole, which in this case weighed perhaps billions of suns. Further observations by Fan and his team over the course of 2 decades uncovered even older quasars, with the most distant one being born just 700 million years after the Big Bang. Like any cosmic object, black holes take time to form and grow. And if we take our current models of the formation of galaxies and black holes under the principle of the 13.8 billion year age of our universe, calculations indicate that black holes should not exist at such scales this early, as they did not have enough time to consume the mass equivalent to billions of suns. Now, if we were to try and explain this phenomenon, astrophysicists state there are only 2 equally strange possibilities. The first is that these black holes probably started off with a standard stellar mass and grew by absorbing surrounding gas and dust. This scenario seems unlikely, however, given that it would go against the Eddington limit, the theoretical maximum luminosity that a body such as a star or black hole can achieve when the forces of outward flowing radiation and the inward acting force of gravity are balanced. In the case of a black hole, if it starts feeding on the surrounding dust and gas aggressively enough, the outpouring of radiation will push them away, slowing down the feeding rate and setting a speed limit for the growth of black holes. The second possibility is that perhaps supermassive black holes can simply be born with improbably large masses, such as when gigantic gas clouds collapse directly into one with a mass of thousands of suns, producing what are known as heavy seeds. But this scenario seems improbable too, because based on our existing knowledge, such large gas clouds should first fracture into stars rather than directly collapsing into black holes. To figure out if either of these 2 scenarios are correct, the James Webb Space Telescope will peer even further back in the past to detect the fainter ancestors of these galaxies, which are likely to have smaller black holes and potentially be in the process of becoming a quasar. While some of the specific findings of this discovery are bound to evolve as the data analysis is peer-reviewed, the broad conclusion that the universe having extremely rapidly birthed out a host of giant active black holes is unlikely to change. It is perhaps the only way to properly explain where Professor Xiaohui Fan's ancient quasars came from. It is important to note that getting to the bottom of the profound questions this discovery raises will require us to start looking back even farther in time and look for black hole masses at much higher redshifts than 11, which corresponds to just 400 million years after the Big Bang. And James Webb is the best chance scientists have of detecting such ancient black holes that have barely started to grow, and are young and small enough for astronomers to identify their approximate birth weight. And with this being just James Webb's 2nd year of operations, it is only a matter of time and enough data that we find the answer to all these questions. Thank you for watching this video, fellow aspiring astrophysicists. If you liked it, please like, share, and subscribe to the channel for more content like this on some of the most breakthrough stories and events in astronomy. And let me know in the comments what you think about this discovery and its impacts on our understanding of the universe. That's it for today, fellow scholars. I will see you all in the next video.